Hi, this is just a mini addendum episode to explain something that I said I'd explain in the last episode on the Second Law of Thermodynamics, but to explain it in the midst of the episode would have broken the flow a bit and it was already getting a bit long. So this is the equivalence of Kelvin and Clausius' statements of the Second Law of Thermodynamics, because they are basically the same thing, even though they sound different. So the episode on the Second Law, which you should go back and listen to if you haven't already, explained that Kelvin's statement of the Second Law is that you can't turn all of the heat that you have into work. You can't convert heat into work with perfect efficiency. Now remember that heat is a sort of disordered motion of molecules moving around in randomized directions, and work is organized motion which can be used to, for example, push objects along. When you apply a force and an object moves in a certain direction, then you've done work and you've imparted energy from those molecules that are moving around into the object that you're pushing. So you can't convert heat into work with perfect efficiency. You always have to put in a little bit more energy to organise the motion of those molecules. That's Kelvin's statement of the Second Law. Clausius' statement of the Second Law is that heat naturally flows from hot temperatures to cold temperatures. If you want to get heat to flow from cold places to hot places, then you need to apply work. So on the surface they sound like they're different statements, but actually they turn out to be the same thing. And you can think about this using some thought experiments. So first off, imagine that you have what you call a Kelvin violator. That is, some magical device that can turn heat into work perfectly. By the way, like I've said before, if anyone wants to sell you such a device, obviously it's not real. Obey the laws of thermodynamics, please. So we have our Kelvin violator. It can turn heat from a hot source into work with no losses. Now imagine that you then use that work to drive another engine, pushing heat from a cold source onto a hot source. Remember, a heat engine is something that lets heat flow in from hot to cold, and it generates work as a result. So running it in reverse and putting work in, you can force heat to go from a cold place to a hot place. So if we have a Kelvin violator that's taking heat from a hot source and turning it straight into work, then we could use that work to drive heat from a cold place to a hot place. And so the net result of everything you've done is what? You've taken heat from a hot place, you've turned it into work, and you've used that to drive heat from a cold place to a hot place, leaving the cold place colder and the hot place the same. So what you've effectively done is that you're taking heat from the cold place and dumping it onto the hot place, which is what Clausius' law says that you can't do. So by violating Kelvin's law, we've also violated Clausius' law. Because the heat flows back into the hot place again, we're forcing heat to flow from cold to hot without doing any work. Similarly, if you have a Clausius violator, it also violates Kelvin's law. So to see this, you need to imagine two engines rigged up together again. One of them can violate Clausius' law, which lets us take heat from a cold place and dump it onto a hot place. The other one is a normal heat engine that lets heat flow from hot to cold and turns it into work. But then you can see how we can cheat the system here. So the normal engine, some heat comes from a hot place, part of it's turned into work and part of it goes to the cold place. But then you can just use your Clausius violator to dump the heat that goes from the cold place back to the hot place again. Since it violates Clausius, you can make heat flow against those temperature gradients without any work. So the net result of these two machines running together, there's no flow of heat from hot to cold because the heat that the normal engine dumps on the cold place is pushed back up again by the Clausius violator. But the engine is doing work. So the net result of these two machines operating in tandem, it's that you're taking heat from a hot place and converting it completely into work with no flow into a colder place. And so you can see that the two statements of the Second Law, although they appear to be different, are in fact substantially the same, and indeed if you break one of them you're also implicitly capable of breaking the other one.